Chapter name is uh, circles. Okay. You learned circle basic things, center, radius, diameter, right? Okay. So now here, not that here. Suppose chord is what? Yeah, line, line on a circle. The line segment joining the two points. Right. This is called chord. A. Okay. This is called chord. And suppose this chord length is chord, another chord is field. Okay. If the chords are equal, subtending angle, subtending angle. No. No, my question is subtending angle. Suppose you look at the clock. Okay. The clock, the top, the rays from top and bottom come to your eyes. So look, your eyes see. This is the one eye. Suppose one tank or something. Okay. Subtending angle in between angle from your eyes. This is called subtending. The top and bottom in between angle, that is called sub. Okay. The chords here subtending means at the center means the rays from here and here and this one. This is called subtending. Subtending at the center. Okay. If the chords are equal, subtending angle also equal. Okay. Reverse also we can say if the angle is equal, chord also equal. Okay. Because the first, right? Okay, consider. Okay. Right first, equal chords of a circle. 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 Subtend equal angle at the center. Subtend equal angle at the center. Equal chords of a circle. Equal chords of a circle. Equal angle at the center. Equal chords of a circle. Subtend equal angle at the center. Equal chords of a circle. Subtend equal angle at the center. Draw this figure. Equal chords of a circle. Subtend equal angle at the center. Equal chords of a circle. Subtend equal angle at the center. Subtend equal angle at the center. Equal chords of a circle. Subtend equal angle at the center. Okay, draw this figure. Then right, if AB equal to CD, which implies angle AOB equal to angle COD. If angle AOB equal to COD, okay, drop out my very speed. This is one. Okay. Next. Yes, sir. Listen. Right. Listen. Suppose when you draw a chord here, what understood what is the chord, right? Which is the longest chord? A, B. If you draw perpendicular, P here. If OP perpendicular to AB, that means AP equal to P. Okay. To prove to remove, you can see the word. Proof not required. It doesn't matter. If you join, look, join this one. You can show these triangles are congruent. Why? OA equal to OB. Why? Radius. OP perpendicular 90, 90. Common. Therefore, these triangles are congruent by what? RHS. Hence, AP equal to P. Not required for you. You just write the perpendicular from the center. 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 The perpendicular from the center of a circle. The perpendicular from the center of a circle. The perpendicular from the center of a circle. The perpendicular from the center of a circle to a chord bisects the chord. The perpendicular from the center of a circle bisects the chord. The perpendicular from the center of a circle to a chord bisects the chord. Okay, draw this figure with the compass and not freehand circle. Okay. Yeah. Okay. Yeah. Okay. No problem. If you draw, no issues. Okay. You just write OP perpendicular to AB, then AP equal to P. The perpendicular from the center bisect. This is the basic theorem of circle. So every year this ask means this idea. Okay. Okay. Now it's converse also this. Listen. If AP equal to PB, okay, then what? This angle should be 90. Okay, write the converse. The line drawn to the center of a circle. The line drawn through the center of a circle. The line drawn through the center of a circle. The line drawn through the center of a circle to bisect a chord. To bisect a chord. To bisect a chord. To bisect a chord. It's bisect a chord is perpendicular to the chord. 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 Okay. Is perpendicular to the chord. Okay. Draw this figure. Then write if AP equal to PB, then OP perpendicular to P. Okay. Okay, you write if AP equal to PB, OP perpendicular to OP perpendicular to AB. OP perpendicular to AB. It's clear now? Both theorems clear on? So only thing what three theorems over now. Hey, hello, listen. The one is equal chords subtends equal angles. The length, listen. The length of the chords are equal. Subtending angle also, center angle also equal. Hello. Okay. Second theorem, the perpendicular from the center bisect the chord. That what the meaning is. Look, suppose here AB is a chord. Okay, this length is 20. If we draw perpendicular here, how much P here? AP equal to PB, how much? 90. Sorry, 10 degree. Sorry, 10 centimeter. That's only. Okay. A converse is if AP equal to PB, then this angle is what? 90. Write the question. The radius of a circle is 30 centimeter. The radius of a circle is 13 centimeter. The radius of a circle is 13 centimeter. The radius of a circle is 13 centimeter and length of one of its chord. Length of one of its chord is 10 centimeter. Length of one of its chord is 10 centimeter. Length of one of its chord is 10 centimeter. Length of one of its chord is 10 centimeter. Find the distance of chord from the center. Find the distance of the chord from the center. Find the distance of the chord from the center. Find the distance of the chord from the center.
Sorry, can you repeat one more time?
The radius of a circle is 13 centimeter. The radius of a circle is 13 centimeter. The radius of a circle is 13 centimeter and length of one of its chord is 10 centimeter. Length of one of its chord is 10 centimeter. Length of one of its chord is 10 centimeter. Okay. Find the distance of the chord. Wait, don't draw. Find the distance of the chord from the center. Find the distance of the chord from the center. Look at here. Read the question. 30. Okay, now.
And length of one of its chord is 10 centimeter.
Okay.
Find distance of the chord from center.
Okay, here this is 30, right? How much AB? 10 centimeter. Draw perpendicular. M. Okay, so AM how much? 5. This is not compass. You need to move. You can see the board. Okay. This is now 5 centimeter. You want to find out OI. I find out OI. OM square is what? OA square minus AM. I don't know. The bigger one, Pythagoras theorem. OA square minus AM. 13 square minus 5. 13, 169, right? 25, 140, right? So OM is what? 12. 12 centimeter. Clear? Okay. Right. Isha, is okay? Elisa,
Yes, sir. Yes, sir.
Tia, clear? Brahmani. Okay. No, you have tomorrow extra class? Eh? No, so we can arrange or competition.
You dictated that, sir.
Okay, so now it's enough. 2 Fridays we finish. Ah. Your draw. Yeah, your draw. It's not a proof, no, that's right. Okay. What is taking here in triangle OM, draw OM. Okay, if you want, you can write draw OM perpendicular to AB. Draw OM perpendicular to AB. Draw OM perpendicular to AB. Okay. Then in triangle, you mark it 13, 5, and dot. Y5, right? AM equal to MB. AM equal to MB equal to 5 centimeter. AM equal to MB equal to 5 centimeter. The perpendicular from the center bisects the chord. The perpendicular from the center bisects the chord. Reason, the perpendicular from the center bisects the chord. Okay. Perpendicular from the center bisects the chord. Okay. Okay. Then you write AM square equal to OS square. That's all you write. Okay. Okay. Finish. Next question. Find the length of a chord. Find the length of the 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 chord, which is a distance of, which is at a distance of, which is at a distance of 5 centimeter. Which is at a distance of 5 centimeter. Which is at a distance of 5 centimeter from the center of the circle. From the center of the circle. From the center of a circle of radius 13 centimeter. Of radius 13 centimeter. Of radius 13 centimeter. Okay. Understood? Find the length of the chord of a circle, which is at a distance of 5 centimeter from the center of a circle 30 centimeter. Okay, here what? This is 13, here is 5. What do you want to find out? AM. Then what? Length of the chord is what? This is 5. Then what is the length of the chord? 10. Double. Okay, no? You, Ananya. What is the first theorem? See, theorem saying what? The perpendicular from the center bisects the chord. Bisect means what? If it is 5, it will be, is also 5. So accordingly 10. Here now. Okay. Scroll also finished. Then no idea. That's okay. Did you understand? Hello. The chord, listen, the chord is 5 centimeter away from the center. That means not perpendicular, That means this is 5. What is the question saying? Okay, 5 centimeter from the center. That means this is 5. You can find this one now. Okay. Eh? No. This is the example I explained to you. Okay. It will be, I think, 12. Okay, then total 5. You got? Eh? Okay. My dear, you don't want to draw two hand for the draw circle. Just one hand, and length of pencil, no, that length, height should be less or equal. Okay. See, this one you turning, you also turn. So, okay. Draw fast. Yeah, getting now? Okay. So how much you got? 24. 24, right? What you got? I asked, my question is chord only. Look, here is 5, right? So AM square equal to 13 square minus 5. 169 minus 25. 140. So AM equal to 12. So AB is 20. Okay, Charlene, okay? Okay. And then, yeah, clear or not? Next. Okay. Ashwini. Okay, next. That's the question. This is star question. If two intersecting chords of a circle, if two intersecting chords of a circle, if two intersecting chords of a circle make equal angle, if two intersecting, if two intersecting, if two intersecting, if two intersecting chords of a circle makes if two intersecting chords of a circle if two intersecting chords of a circle make equal angle with the diameter. Okay. if two intersecting chords of a circle makes equal angle with the diameter passing through the point of intersection. Passing through their point of intersection. Passing through their point of intersection. Prove that chords are equal. Prove that chords are equal. Okay. Read the question. Okay. Look at here. Hey, don't do anything. I'll explain. Good question. Two chords. Okay. One is here. A. Don't try anything. Wait. Here. C. These two chords intersecting at a point E. Square of two intersecting chords of a circle makes equal angle with the diameter. So we are drop one diameter. It is passing into the length. This is the diameter. Oh. You can call it name. Okay, P, Q the diameter. These two angles are equal. Correct or not? First say correct or not? Listen. So the question: if two intersecting chords of a circle make equal angle with the diameter passing to a point of intersection. That means one diameter passing through this E. That makes equal angles. Then the chords are equal. This is the question. Okay. Question clear or not? Question is AB and CD are two chords. Okay, I'll give that everything I'll give. AB and CD are two chords intersecting at E. P, E, O, Q is the diameter. Such that angle A, E, Q and D, E, Q equal. Okay. To prove that AB equal to C. This is the question. Question clear or not? Right? Is it okay? Because circle will continue next year also. That's the problem. Okay, you'll face issue not this year also. This year, next year also you'll face. Okay, circle continuation circle. Okay, everything continue next year. Don't throw your book. Okay, okay, we are refer. Okay, so here surface area one first chapter is there. Second chapter is continue. Third chapter everything except 2-3 chapters only new. Okay, so here AB and CD are two chords intersecting at E. The diameter passing through E, which makes equal angles. That this angle and this angle, I call it 1 and this is 2. Okay. So that AB equal to C. Okay. How AB and CD equal? We'll first say about. Okay, listen. If the distance equal, listen. I didn't say that. Look at it. Yeah. Okay. Suppose one chord here, second chord here. Okay. A, B, C, D. If this distance O, P, and Q. If OP equal to OQ. Okay. If OP equal to OQ, then what? AB equal to C. Equal chords are equal distance from the center. Right first that. Equal chords are equal distance from the center. Equal chords of a circle are equal chords. Equal chords are equal distance from the center. Equal chords are equal distance from the center. Right first that. Equal chords are equal distance from the center. Equal chords are equal distance from the center. Equal chords are equal chords of a circle are equal distance from the center. Equal chords of a circle are equal distance from the center. After that, clean the space so that I will show that. Equal chords of a circle are equal distance from the center. Here. Okay. Listen. What is that one now? Look at it. Suppose two chords. Hey, listen. Two chords here. A, B, and these are two chords. Okay. If O, M, and N are equal, then what? These chords are equal. You can show this one. Not need to prove. Why? Suppose you join this one. You join this. We can show these triangles are counted. Okay. How? uh, eh, eh? Yeah, this is equal to this one, and this distance already given. This is 90. Therefore, these triangles are congruent. Then AM equal to C. AM equal to C means then doubling codes also. But not need a proof. Okay. What is what now? Equal chords of a circle equal distance from the center. Okay. Right now, draw this figure. That we come back to here. Okay. Equal. What is what? Equal chords. Equal. Equal chords. Equal chords of a circle are equal distance from the center. Equal chords of a circle are equal distance from the center. Equal chords of a circle are equal distance from the center. Equal chords of a circle are equal distance from the center. Equal chords of a circle are equal distance from the center. Equal chords of a circle are equal distance from the center. Equal chords of a circle are equal distance from the center. Draw this figure. Okay. Full error. Okay. Yeah, everything. Equal chords of a circle are equal distance to the center. Well, right? If AB equal to CD, if AB equal to CD, don't need to prove. If AB equal to CD, if AB equal to CD, then OM equal to OI. Then OM equal to OI. Clear now? Equal chords of a circle, equal chords of a circle are equal distance from the center. That means if AB equal to CD, then OM equal to OI. Okay. Clear now? Next theorem. Chords of a circle are chords of a circle, chords of a circle, chords of a circle, which are equidistant. Chords of a circle which are equidistant from the center are equal. Chords of a circle, chords of a circle, chords of a circle, which are equidistant. Chords of a circle, chords of a circle, which are equidistant from the center. Chords of a circle which are equidistant from the center are equal. Chords of a circle which are equidistant from the center are equal. What are the meaning here? No, here figure. If OM equal to ON, then AB equal to C. That's all. Perfect. Okay. No? Okay. Okay. Look. Okay. Finish. That means here what is given? OM equal to ON, then AB equal to C. Okay, now listen. Just four theorem now finish, right? Just conclude. Okay. The first one, equal chords are equal distance. No. The first one is what? The chord equal chords up to equal. Okay, listen, not right now. First theorem, if AB and CD, anywhere CD or PQ is all equal. If AB equal to CD equal to what is one? PQ, right? Okay. PQ, that means center here. Angle AOB equal to COD equal to POQ. This is the first thing. Right? Not that man. The theorem number one is what? What is the theorem? Equal chord, subtend, equal angle at the center. Equal chords, subtends, equal angle at the center. Oh, you sleeping? Hello. Okay. Okay. Right now school no. Then why tired? Okay, if it's school, okay, I agree. A very long transport. Okay. You holiday sleeping now. Okay. Okay. You maybe slept up to 11 o'clock. Right? 10. Then what? Any other activity today? Then what? Okay. So still tired. Okay. Look at here. Now enough oxygen in your body. That's why you're sleeping more. Okay. Okay. That's a symptom. Okay. Look, you check maybe 90s or the oxygen. Okay. Okay. You want to check now? Okay. Listen. Listen. Here AB. If AB equal to CD equal to PQ, then angle AOB equal to COD equal to PQ. Okay. Equal chords. Subtend. Equal angle at the center. What? Angle center. Its converse is what? If the center angle is equal, chords also equal. Okay. Second theorem is the first theorem. Are you okay now? First theorem, the perpendicular from the center bisects the. This is common theorem. The perpendicular from the center bisects the chord. A B O here. If P if OP perpendicular to AB, which means AB equal to P. This is the second theorem. Third theorem. Okay. Then fourth one, if AP equal to PB, that means angle P 90. Okay. Now back here now, equal chords are equal distance to the center. That means, okay, here I can. If AB equal to CD, OF equal to OF. That is the third thing. Okay, fourth one, if AB equal to CD, then what? OM equal to. Where are all? Okay. Now back to our question. What was the question now? No. What's the question? We were pending one question now. Okay. If two intersecting, listen, don't write now. Close the book and sit. Okay. Just relax. Then batch B tomorrow, just because of it. Yeah, right? Batch A Sunday. Hmm? So here given is what? Given is angle, okay, angle 1 equal to angle 2, right? Angle 1 equal to angle 2 is equal. So what? AB equal to C. Clear now? What I did now? Construction from OA perpendicular and ML perpendicular. Because not okay. You draw correctly. Our requirement is what? AB equal to C. Given is what? 1 equal to 2. What do you have to prove there? To get AB and CD equal, what do you have to show? What? Okay. You didn't go for the practice play, dance. Not going. Okay. Now our requirement is AB equal to CD. Okay, requirement is AB equal to CD. Then what you have to show? Okay, if OM equal to ON, what's your name? L. Okay, if you can show OM equal to ON, then finish. Why? You just prove OM equal to ON. Then we can write what? Equal chords are equal distance from the center. No. No. This, equal distance. Second converse is what? Distance from. If the distance are equal, chords also equal. Right? Okay. How to show this time? Show these triangles are congruent. How? That's why congruency is everywhere. Okay. OA equal to OA. OE equal to OE common. Then angle 1 equal to angle 2 and M equal to N. Right? By construction. That these triangles are congruent by AS. Hence, OM equal to ON. Right? If OM equal to ON, then what? AB equal to CD. Finished now. Right? Are you okay? Okay, then right. Draw figure. Use the figure. Okay, draw figure. I'll give the note. Okay. You just draw figure only and mark it. Okay. Right. Given AB and AB and CD are two chords. AB and CD are two chords. AB and CD are two chords. AB and CD are two chords intersecting at E. Intersecting at a point E. AB, listen, right like this. AB and CD are two chords of a circle with center O. AB and CD are two chords of a circle. AB and CD, AB and CD are two chords of a circle intersecting at a point E. Then PQ is a chord. PQ is a chord. PQ is a diameter. PQ is a diameter. PQ is a diameter passing through E such that angle 1 equal to angle 2. Such that angle 1 equal to angle 2. Angle 1 equal to angle 2. Angle 1 equal to angle 2. Okay. To prove AB equal to CD. To prove AB equal to CD. AB equal to CD. Okay. Then construction. Draw OM perpendicular to AB. OM perpendicular to AB. OM perpendicular to AB. OM perpendicular to AB. And ON perpendicular to CD. ON perpendicular to CD. ON perpendicular to CD. Okay. What you have to prove here or no? Right. Right. Proof in triangle OME, OME and ONE. ONE. Angle M equal to angle N 90 degree. Angle M equal to angle N equal to 90 degree by construction. By construction. Then OE equal to OE common. 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 Okay. Then angle 1 equal to angle 2 given. Angle 1 equal to angle 2 given. Angle 1 equal to angle 2 given. Okay. Right. Therefore, triangle OME congruent to triangle ONE. OME congruent to triangle ONE. ONE. Okay. Hence, OM equal to ON. OM equal to ON. CPCT. CPCT. Therefore, AB equal to CD. AB equal to CD. Okay, bracket right. Full right. Chords of a circle. Chords of a circle. Chords of a circle. Chords of a circle which are equidistant to the center. Chords of a circle. Chords of a circle. Chords of a circle which are equidistant from the center. Which are equidistant from the center. Chords of a circle. Chords of a circle which are equidistant from the center are equal. Okay. Finished now, first one, okay. Next question. Huh? Which one other angle? P. Because that are the same now, it's a vertically opposite angles come, right? What is the issue? But the question is saying with the diameter. B is equal now. If other side, if this side is equal, other side also equal. Right? Okay. Next. Right. Two equal chords of a circle. 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 Two equal chords of a circle within the circle. Two equal chords of a circle within the circle. Two equal chords of a circle within the circle. Prove that segment of one chord. Prove that segment of one chord are equal to the corresponding segment of the other chord. Okay, your class may be done this question. Okay, listen. If two equal chords of a circle intersect within the circle, prove that segment of one chord are equal to the corresponding segment of the other chord. Listen. Once again, if two equal chords of circle intersect within the circle, if two equal chords of circle intersect within the circle, prove that the segment of one chord is segment of the other chord. Okay.
Sir, could you repeat what to prove?
Okay, just wait a minute. Look at here, the figure, if the things are if two equal chords of a circle intersect within the circle, prove that segment of one chord are equal to the corresponding segment of the other chord. Same figure only actually, look at it. Hey, hello, don't write now, wait. Same figure only, but here given is what? Read. If two equal chords of a circle, given is what? AB equal to C. Okay. If two equal chords of a circle intersect within the circle, prove the segment of one chord. That means you have told that AE equal to DE and CE equal to B. That's the question. Question clear? Listen. If two equal chords of a circle intersect within the circle, that means same figure. Prove that segment of one chord. Prove that segment of one chord are equal to corresponding segment of the other chord. That means, look, this without this construction, I'll show you. Listen. Now construction. Given is what? AB equal to C. To prove what? AE equal to DE. And then what? BE equal to C. This is the only method. Okay, perfect. With one and two, not given. Okay. Okay. Now listen. Finish. I'll give everything. Given and everything I'll give. Okay. The figure here is to E. Okay. Okay. Right. Given C. No, not angle. See, this AB and CD intersect at E. This two parts, no, this is the one part, AE. That part equal to ED. And this part equal to this. That's all. Okay. Okay. Right. Given AB and CD are two chords. AB and CD are two chords. AB and CD are two chords of a circle. AB and CD are two chords of a circle with center O. With center O. With center O. Okay. With center O. Okay. Chord is not required. Okay. If it is there, no problem. But we need this one. Optically something. If you draw, not draw, just keep it there. And it's not wrong. Okay. Then to prove AE equal to CE, AE equal to B, AE equal to what? DE. Correct or no? And BE equal to C. B equal to C. Clear or no? Look at here. This part corresponding this part. This part equal to this. Okay. Then construction. Draw OM perpendicular to AB and ON perpendicular to C. OM perpendicular to AB and ON perpendicular to C. Look, don't write now. Stop. Okay. OM perpendicular to AB. What's the meaning? OM perpendicular to AB means AM equal to what? Huh? AM equal to BM. Correct or no? Why? Listen. OM perpendicular to AB. That means AM equal to BM. Why? Reason what? Perpendicular from the center, vice versa. Similarly, ON perpendicular to CD, right? That means DN, right? CN, where's CN? Oh, CN equal to CN equal to ND. Okay, this is number one. Okay. Right? Hello. Listen. DN equal to C. No problem. Okay. Given is what? AB and CD are equal chords. AB and CD are equal chords, right? And to prove AE equal to ED, BE equal to C. We did constructions. OM perpendicular to AB, that means this equal to this one, and this equal to this one. And now, can you show these triangles are called? Triangle OME, OLE are called U. What's the name? Anjana. Okay. OME and OLE are complementary. Any side, any angle equal. OE com. L, second. And 90 degree. Okay. One more you require now. U. These two triangles, two angles already set. Now we have to say side on. One side already set. Okay. What's your name? Fasi. Okay. M equal to NE. Given the question for you, especially any particular the student didn't get that reason. Which side equal? OM equal to ON. Why? No. OM equal to ON. What is the reason? Not construction. Since the chords are equal, no, distance also equal, no. You understand now? Chords equal already. But distance is equal. Correct? The reason is what? Chords equal. AB equal to CD, so distance also equal. Are you okay now? Right? The reason is what? Chords equal, so distance also equal. So OM equal to ON. Okay? And OE equal to OE common. M equal to N 90 degree. Which congruency? RHS. Correct or no? Hypotenuse. This is hypotenuse. Because M90, hypotenuse and one side, hypotenuse on one side, right? Correct or no? Hypotenuse, okay or no? Okay. Hence, ME equal to EN. ME equal to EN. Number 3. Agree or no? Right? What are you doing? Looking at the compass, looking at the tip of the compass, looking at like a art movie, like that only. Come on. Right? Art movies like that. Take the water bottle. The actor first look at the song, read, and okay, very boring movies. Okay, then digital turn. Okay, then around 20 minutes over. Okay, that movie. Like that, one serious question we are discussing that time. She is looking at the tip of the what enjoyment is that tip of the compass, right? I understand what is this. If you're boring, you don't come. Okay, your friend also like that argument, right? Okay. So I'm explaining here. I have only one Friday only for me free. Okay, then I'm spending for you that time. Okay, so you're not listening here. So don't write. We are all discussing that part, right? Actually, in batch A, you batch B, right? Okay, that's the reason. Okay, batch A not like that, correct or no? Very live class only batch A. Everyone discussing only. Everyone they have their own reasons and very live show. In batch A, right? Okay, so what we are then I never boring in batch A because everyone have idea, different ideas come with a different idea. This is what looking at the combos. What is this one, right? Okay, I just like movies, some movies there, art movies and all like that. Okay, okay. The actor just throwing what a stone to the water. Then he looks at the bubble and all. Then each guys look at like that. Okay. Actually, real movie like that only. Okay. Okay. Some movies I saw recently, one Malayalam movies. Everyone crying. We paying 2.5 dinner and crying for what? Sad stories. Malayalis all crying. They never cry in a real sad things they have. Okay. Okay. So this is a movie sad story. They're crying. One lady taking towel and crying. For what? He paid 2.5 dinner and crying. Okay. So that way, sit outside. No. Okay. Okay. Come to the point. Okay. Because we lost time. Okay. Everyone, 10 students. Oh, 13. 1, 2, 4, 6, 8, 10, 12, 28 students into 2. 56 minutes lost. Okay. Look. Okay. Now we are restart from okay. What is given here? AB equal to C. Chords are equal. AB equal to C is given. Immediately we come to know OM equal to OM. Correct or no? Why? If the chords are equal, distance also equal. If the distance equal, what? Chords also equal. Now? Okay. So in triangle OME and ONE. Okay. M equal to N, 90 degree by construction. Then OM equal to ON, chords are equal. And OE equal to common. Therefore, these triangles are conquered by RHS. Hence, ME equal to E. Okay. Our requirement. Okay, listen here. You add 1 and 3. Whatever. Add 1 plus 3. AM. Listen. AM plus ME equal to BM plus EN. Right? Correct or no? BM. No. Okay. AM. AM will see. No, wait. First part. Okay. AM plus ME. Correct. Second part BM. Where BM? Second part DN. Oh, this one, right? Correct or no? Second, this part adding DN and what? EN, right? So you make it okay. When adding, we'll get what? D here DN, right? Listen, 1 and 3 add. Listen, don't take this part. 1 and 3. What happened? AM plus ME equal to BM. That is BM. We are down only. Okay. B. Okay. Here AM equal to correct or not? DN equal to what? CN. Okay. This one EN. Now EN plus what? DN. So you can change it to here CN. Okay. What you get? EN plus DN. So what happened? AM and ME what? A. AE equal to what? DE. Okay. Right now. Right. ON perpendicular. Prove. ON perpendicular AB. OM perpendicular to AB. Hence, AM equal to BM. AM equal to BM. Only number 1. Perpendicular from the center, vice versa. 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 Okay. Wait. Listen, OM perpendicular to AB, which implies AM equal to BM. Clear? Number one, perpendicular from the center, bisect the chord. Perpendicular from the center, bisect the. Okay. Hey, listen, don't, right, I'll give practice. Okay. AM perpendicular to BM. Similarly, OL perpendicular to CD, ON perpendicular to CD, that is ON perpendicular to CD, DN equal to CN, number 2. DN equal to CN, number 2. Okay, this is not perpendicular to the center, vice versa. Perpendicular to the center, vice versa. The triangle OME and ONE. Okay. Angle M equal to angle N 90 by conception. Angle M equal to angle N 90 degree by conception. Angle M equal to angle N equal to 90 degree by conception. Then OM equal to ON. OM equal to ON. Equal chords are equal distant from the center. Equal chords are equal distant from the center. Okay. Then OE equal to OE common. OE equal to OE common. Okay. Then therefore triangle OME OME congruent triangle ONE RHS congruence to RHS congruence to. Hence ME equal to LE. There. Right. After that, listen. Okay, you know what is called ME equal to ME equal to what? E. Number 3. You know that AB and CD are equal. So that means AM equal to ND. Correct? Number 4. Right. Since AB and CD are equal, since AB and CD are equal, AM equal to DN. Okay, number 4. Then adding 3 and 4. Adding 3 and 4, we get AM plus ME equal to EN plus DN. What do you call it? AM plus ME is what? AE. AE equal to DE. Okay, this proves the first part. This proves the first part. Okay. Okay. Then, where now what do you show? B and CD equal, right? This is equal 5. Okay, then AB equal to, you wrote here, AB equal to CD, you wrote, no, somewhere, where you wrote? Like AB minus AE, right? AB minus AE equal to AB minus AE equal to CD minus DE. What is that? AB minus AB minus AE equal to CD minus DE. What is that? B equal to C. B equal to C. Clear now? Okay, now just go through this note. It's still a complicated note. Okay. Okay. Clear now? Just go through the note. Then I'll check it. Clear any doubts. Okay. Okay. Is it okay now? Okay. Okay. Next. Right. If two equal chords of a circle, if two equal chords of a circle, if two equal chords of a circle, if two equal chords of a circle intersect with the circle, same type, same question. Okay. If two equal chords of a circle intersect within the circle, prove that the line joining the point of intersection, the line joining the point of intersection, the line joining the point of intersection to the center, the line joining the point of intersection to the center makes equal angle with the chord. makes equal angles 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 with the chord. Question again. If two equal chords of circle, if two equal chords of circle intersect with the circle. Okay. Prove that line joining the point of intersection to the center makes equal angles with the chord. To make the equal angles with the chord. Listen. This question exactly like today's first question. Hey, check the first question. First question, equal angles are given, right? First question, angles are equal is given. First question, angle 1 equal to angle 2 given. Here what? Chords are equal. Just opposite only. Correct or no? In the first question, angle 1 equal to angle 2 show that AB equals CD. Here is what? AB and CD are equal. Show that angle 1 equal to angle. Can you try this one? Try. Okay. Try this one. Very sure, no? Right. Exactly like for every first question. Okay. How we did first question? Same idea only. Okay. two chords, same figure you draw. AB and CD intersect at O. Okay, E here, the chord equal one. Okay, you join this one, join this. We are what you have shown? M here, N here. What is given? So what is given? AB equal to CD and intersecting at E. Okay, to prove what? Angle 1 equal to angle 2. Show these triangles are congruent. Okay, M and N 90 degree. This one and this one equal. Why? Equal chords are equal distance center, right? This is what common. Therefore, angle 1 equal to angle 2 CBC. Can I know? Finish? No, it's okay. No, you proved this triangle. What you did? Same figure. M equal to N 90 degree by construction. OM equal to ON. Equal chords are equal to the center. OE equal to OE common. Therefore, these triangles are congruent by what? RS. Hence, angle 1 equal to angle 2. So, right. If a line intersects with concentric circle, what do you mean by concentric circle? Circle with the same length. Circle same radius is what? Circle same radius. Congruent circle. Okay, right. If a line intersects, if a line intersects, if a line intersects, if a line intersects two concentric circles, if a line intersects two concentric circles, if a line intersects two concentric circles, okay, with center O, with center O, with center O at A, B, C, D. A, B, C, D. Prove that AB equal to C. Prove that AB equal to C. Prove that AB equal to C. Okay.
Sir,
Perfect.
what do you mean by concentric circles?
What do you mean?
What do you mean by concentric
Concentric
circles?
circle means circle with the same center. Circles with the same center. You can draw many circles now. Like, look, one circle, another one. These are all called concentric circles. With same center. Okay, we have shown that AB equal to C. Okay. Hey, hello. Any idea? Oh. Draw perpendicular. Listen. Wait. Hello. Listen. Draw OM perpendicular to the line. A. Line, there is L here. L. Okay, don't write down. Draw OM perpendicular to the line. See OM perpendicular to AB. AD, whatever. AM equal to MD. Number one. Perpendicular from the center, bisector. OM perpendicular to BC. Then what? BM equal to MC, right? Correct or no? Listen. OM perpendicular to AD. That means AM equal to MD. And OM perpendicular to CD. BM equal to MC. So what happens then? Subtract AM minus BM, right? Equal to MD minus CM. What is that? AB equal to C. Right? Right. After that, I'll give you 3 minutes break. Then what? You want to go? Yeah? Are you right? Okay. After this question, I'll give you. I got the next part. I thought you want to go. Okay. Okay. You write just OM. You can write OM perpendicular to AD. That means AM equal to MD. Number one. OM perpendicular to BC. That means EM equal to MC. Subtract it equal to. Right. Then what is this? Will be done in class. Right. Okay. GIS also done. Right. Okay. So now, after that, another section based on the angles. Okay. Just 2 minutes break rest. So next slide, theorem. So the theorems all we learned, not learned before the next part. Okay. The angle subtended by an arc. This proof may be school, if it is required, we can do it. Okay. The angle subtended by an arc. The angle subtended by an arc. The angle subtended by an arc. The angle subtended by an arc at the center. At the center, the angle subtended by an arc at the center. The angle subtended by an arc at the center. The angle subtended by an arc at the center is double the angle. Is double the angle. Is double the angle subtended by it. Double the angle subtended by it. Double the angle subtended by it at any point on the remaining part of the circle. At any point on the remaining part of the circle. At any point on the remaining part of the circle. Question again. I'll read again. The angle, listen. The angle subtended by an arc. Listen, the angle subtended by an arc at the center. The angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. Remaining part of the circle. Okay. Listen. Not right now. This proof I'm not doing now. Just explain it. Look. Suppose an arc here. Arc means what? Close the door. Arc means what? Part of circle. Look. Suppose subtending angle like this is the subtending angle. AOB. This angle. Okay. This angle is called center angle. Look, the angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part. That means look at this angle. P. Suppose that means this is 30, this will be how much? 50. This is half. Listen. Read. Angle subtended by an arc at the center of a circle. Center is double the angle subtended by any point of the remaining part. Any point. Look at this here. This is also enough. any point. This all will be half of half. This is the figure. Okay. Okay. You draw nice figure one. Okay. AOB. Okay. Right. Angle AOB equal to 2 times of angle AP. This figure is okay. Okay. Right angle angle AOB equal to 2 times of angle AO. Okay, right. Next theorem. Angles the same segment are equal. Angles the same segment of a circle are equal. Angles in the same segment of a circle are equal. Finish. Angles in the same segment of a circle are equal. Angles in the same segment. All theorems you have learned. Angles in the same segment of a circle are equal. Next week this chapter solution is what right? Okay, look at here. Same segment. Listen, not right. A, B, P here. This all Q. Any angle like this. Okay, X. This all angle for E. But why? Take the same segment. You got to check angle passing through AN. Understood now? And vertex anywhere that all will be equal. Okay, draw this figure. Angle in the same segment are equal. Yeah. Yeah, this whole segment, part of the segment, angle same segment are equal. Eh? No. This sector segment. Other one code. A segment means a part. You just write angle ASB equal to ARB equal to APQ, APB equal to angle AQB equal to angle AX. Like that is called angle. Angles in the same segment are equal. Angles in the same segment are equal. Okay, angle. You write like this. Angle ASB equal to angle ARB equal to angle APB equal to angle AQB equal to angle AXB. Okay. We now finished. Okay. So this one finished, right? Okay. Now next theorem. Semicircle is 90 degree. Angle in a semicircle is 90 degree. Angle in a semicircle. Right. Angle in a semicircle is 90 degree. Angle in a semicircle is 90 degree. Okay. This is 90 degree. Angle in a semicircle is 90 degree. Okay. Uh, Manvik, this is your question is not genuine. Okay, tomorrow is another chapter only. No, this is extra question. If you have test on Sunday, no problem. No need to attend it. No, tomorrow you can study for your Sunday test. There is no issue. Okay. Okay. Yes. Okay. Now, just go through theorems because if it, then all I can do the questions. Okay. Especially these three. No. See, listen here. One question, doubt. An arc P here, Q. This one second. Any angle passing through this all should be equal. Not this one. Should be inside, not inside, not like this. On the segment. Check it out. These theorems should be thorough. How many theorems today finish? I can do next question. Okay. Okay. Hmm. Okay, check it out. I'm not giving you questions because you have to learn this, so then all I can do it. Okay. This chapter will continue next Friday. Okay. School will release now. Circle. That means it's all finished. Right? Eh? Chapter. You didn't attend school. Ah, circle very rich year class. Yes, this is one. Okay. Next class I'll do then one more week I'll extra question finish. Okay. And by the time I'll when their exams are over, I'll do the in class also. Okay. Okay, check now theorems. Okay, all the theorem, make sure. The transport, what time is transport? How you go? You. Okay. What time transport comes? 6 or? Eh? When? Time? When the crossover? What time crossover? 6, no? Okay, so let's see one easy question we can work out of. Okay, listen. Because since okay, one more point I have to do. Right, cyclic coordinate. Cyclic coordinate. That also. Cyclic coordinate. Cyclic coordinate. Cyclic coordinate. Right. A quadrilateral inscribed in a circle is called cyclic coordinate. A quadrilateral inscribed in a circle is called the cyclic coordinate. A quadrilateral inscribed in a circle is called cyclic coordinate. A quadrilateral inscribed in a circle is called the cyclic coordinate. Draw this figure. It's called. Okay, draw this figure. Okay. Right. If the sum of a right, sum of either pair of opposite angles of right. The sum of either pair of opposite angles of a cyclic coordinate is 180. The sum of either pair of the sum of either pair of the sum of either pair of opposite angles of a cyclic coordinate is 180. Opposite angles of a cyclic coordinate is 180. That means what? Angle A plus angle C 180. Right, that one. Angle B plus angle D also 180. Angle B plus angle D 180. Angle A plus angle B 180. Angle B plus angle D 180. Okay, listen. Another point, one more last point. If A plus the 180, then what? It is cyclic coordinate. Opposite, converse, right? If the sum of a pair of opposite angles, if the sum of a pair of opposite angles of a coordinate, if the sum of a pair of opposite angles of a coordinate is 180 degree, if the sum of a pair of if the sum of a pair of opposite angles of a coordinate is 180 degree, then the coordinate is cyclic. Then the coordinate is cyclic. If the sum of listen, if the sum of a pair of opposite angles of a coordinate is 180 degree, the coordinate is cyclic. Coordinate is cyclic. So next class, we are according to the schedule you are prepared. I think quadrilateral, right? And but next Friday, we start with okay. Not this Friday, okay.